Okay, so this is the station for your experimental design notes, and it says fill in the notes on the left side. So we're going to fill in these blanks here on the left side. You'll do on the right at a later time. So we're talking about experimental design, and that kind of centers around the scientific method. And the scientific method is a way to ask and answer scientific questions by making observations and doing experiments. And for whatever reason, this blank isn't filling in, but as you can see here, it's making observations. So the scientific method has pretty much 6 main steps. You have to ask a question or make an observation. There has to be some reason why you want to experiment. You're going to make a hypothesis, which is your educated guess, educated because you've probably got some background knowledge on what you're testing. Do an experiment, collect some data. When you get that data, you want to analyze it, figure out what's going on. When you do several repeated trials, you'll analyze that data statistically, look for averages and look for trends. And then you can draw conclusions. So really, it's kind of repetitive, and really you could argue that repeated trials would actually come up here after analyzed data, that you would continue to repeat the trials before you draw conclusions. But also, once you draw conclusions, other scientists should repeat your work as well to see if they come up with the same conclusions. And that really embodies the whole scientific method. So let's talk about the parts of an experiment. That's what we call experimental design. How do you design an experiment? One of the first things you have to do is identify your variables, what's going to change and what's going to stay constant. So there's a couple types of variables, the first one being the independent variable. And the independent variable is the part of the experiment that you actually change. That's what you're testing. And you guys will go back and look at a scenario, but think of a simple experiment, like if I want to figure out which popcorn brand pops the most. My independent variable is the different brands of popcorn. If I want to figure out which batteries last the longest, my independent variable is the different types of batteries that I test, because that's what I'm changing. Maybe I buy Rayovac and I buy Duracell and Energizer. Those are the variables. That's what I'm changing. Then we talk about dependent variable, and a dependent variable is what you measure in the experiment. So it's actually what's affected during the experiment. The dependent variable responds to the independent variable, thus the terminology. It's dependent upon the IV. So the DV, the dependent variable, is what you're measuring. So if I was talking about that Energizer and Rayovac and Duracell batteries, my dependent variable would probably be how long they last, time in minutes or time in seconds, or however you choose to measure it. If I was talking about the popcorn, which popcorn works the best, I would probably measure that by which bag of popcorn has the least amount of kernels that were unpopped. So you're doing some type of data collection here. You have to identify the IV and the DV really before you can make a hypothesis, because the hypothesis should embody the IV and the DV. So it's the prediction or educated guess made before you do the experiment. A lot of times you see them written if the IV, then the DV, but it doesn't have to be that way. So for example, if I was talking about the batteries, I might say something along the line of if Energizer, Duracell, and Rayovac batteries were tested, then Duracell will last the longest amount of time. So I'm identifying what I'm testing and what I'm measuring, and then I'm actually making a prediction. I don't have to do this whole if-then, though. I could say, when testing Rayovac, Energizer, and Duracell batteries, Energizer batteries will last the longest. Notice I don't put anything in there about I think or I guess. It's a prediction, but you want to make it as if you think it's a fact already. You don't want it to be iffy. The control, this part of the experiment trips up a lot of students. The control is a group or individual used as a standard for comparison for checking the results of an experiment. So the control does not receive any experimental treatment or change. Not every single experiment has to have a control, but for our purpose, we're going to do lots of practice experiments that do. So, for example, in the performance assessment you did, the control actually was the penny with the drops of water on it, the regular real penny. Maybe you tested the real penny versus the fake penny. Maybe you compared the real penny to a quarter. Maybe you compared cold water on a penny versus hot water on a penny, but the control was the plain old penny. If I was doing the experiment with batteries, maybe my wife always buys me Energizer batteries for my game controller. And so I want to find out, hey, is Duracell really better? Or am I better off buying the cheaper, Walmart brand batteries? Then the batteries that I always have, the Energizer, that would be my control, and I'm going to compare the other brands to it. So you get the idea, is your control is something you compare it to, but it can also be the non-treated group. For example, let's say I want to figure out if fertilizer makes my tomato plants grow better, then the control would be a group of tomato plants that has no fertilizer, and then I'd have a group of tomato plants that I put some Miracle-Gro fertilizer on, and I see which one does better. I can say, oh, the fertilizer works better compared to no fertilizer. Constants is another important part of the experiment. That's what stays the same. When you are doing an experiment, you want to only change one variable at a time, so that you can be confident that your change is what really affected the results. Let's say I'm doing the Energizer battery test and I use my Xbox as the example, then maybe some of my constants are same exact video game controller. I'm going to play the same video game because maybe each game affects how well the controller works or how much energy it uses. Maybe the same person playing the game. I'm going to maybe even do it at the same time of day. Those things are all going to stay constant, so I can really just test which battery is better. If I was popping the popcorn, maybe a constant is how long I pop each different bag of popcorn in the microwave. Maybe I'm making sure that each bag is the same size. Those would be some constants. So in your experiment with the coins and the water, you probably made, maybe one of your constants was you used the same temperature of water all the time. Maybe one of your constants was you held the eyedropper the same distance from the penny or whatever coin you were using. The water itself was a constant. You were using water, not orange juice or alcohol or other things. So you always want to identify constants and only change one variable. So that means it would be wrong to test too many things at once. If you tested hot versus cold water on a penny versus a real penny versus a fake penny and a real quarter versus a fake quarter, you've got too many variables going on. You should just stick to one thing. And then, of course, repeated trials. Scientists repeat the experiment the same exact way to see if the results are consistent all the time. If the repeated trials are not consistent, then the results aren't actually valid. So, of course, there could always be an outlier. If I did the same thing 30 times over and once or twice the data really was off, that might just be a simple mistake. But I want to keep getting the same results each time, or else my data isn't very valid. So, good scientists are going to repeat things 3 or 4 times. When you're talking about medical things, you're going to repeat hundreds of times maybe. But for the purpose of our class and for the purpose of your performance assessment, you have to at least do it twice. 3 times is even better. And we'll talk a little bit more about data tables and graphs and such at a later time. So that's it for this.